Alright, our first section that is probably not reviewed for most of you. Some of you may have seen this stuff before, but a little more in-depth. Some material you had before. As here, we're talking about complex numbers. So the idea here is that if we're working with real numbers, the numbers we usually work with, college algebra, got whole number, positive, negative number, fraction, irrational numbers like square root 2, those things. Those are real numbers, but if we're working in real numbers and we have a situation like this where we want to take the square root of a negative number, in particular the square root of -1, normally we would say that's undefined in real numbers. But what if we do give it a definition? Well, if we do that, then we expand our number system into this number system we call the complex number. They can be very, very useful. So here, what we're going to do is anytime we have the square root of -1, to call that I, the imaginary unit, lowercase I. So if I is the square root of -1, another relationship we can say is that if we have I squared, it's going to and in order to have a complex number, the standard form, the standard way we write a complex number, this form, A plus BI form, where A and B real numbers. The thing we're introducing is this I. This is a complex number. The A part called, so whatever number we have for A, it's what we call the real part of our complex number. And whatever number goes with the I, call that the imaginary part of our complex number. So not with the I, just the number with the I is the imaginary part. Our goal in this section is to be able to work with complex numbers. We want to be able to do basic operations on these things. So add, multiply, divide, that type of thing. Okay. So let's get two complex numbers here. We're going to 2 plus 3i plus 7 minus I. So these are two complex numbers. And remember, the I here is not a variable. I represents the square root of -1. That's our imaginary unit. But most of the time, we can treat I just like a variable. So these things are just like our algebraic expressions as far as working with them. So what we're going to do here is we're going to combine like terms. So the part without the I, our real parts, we're going to combine those. So we've got 2 plus 7. 2 plus 7 will give us 9. And we will combine the parts with the i's. So we've got 3i minus I, minus 1i. 3i minus 1i, that's positive 2i. And then this is in our standard A plus BI form. So this would be what we get when we add these two complex numbers together. If we're subtracting, it's almost just as easy. Just remember we need to distribute the minus sign. So what if we had the same problem but we were subtracting? So 2 plus 3i minus 7 minus I. So how would that go down? This time we're subtracting. So we would have 2 minus 7. Okay. So, and then we would have 3i minus -I. Okay, so a good thing to do is to take this negative sign and distribute it. Both numbers in the second complex number. Okay, both parts of the second complex number. So if we rewrite, then we've got 2 plus 3i, distributing the minus, so that's minus 7, and minus a negative I turns into plus I. So now, we've got 2 minus 7 gives us negative 5. We have 3i plus I get plus 4i. So just remember, if you're subtracting, to distribute the minus sign. That's the same thing we did with algebraic expressions, so hopefully that's not too new to you. Okay. What about for multiplying? So maybe 5 times 3 we do there. We still just use our regular distributive property. So again, this is just like we would do an algebraic expression. Okay, we've got 5 times 3 gives us 15. 5 times 4i gives us 20i. Like that too, so I'm going to read 15 plus 20i. Lots of times we can just treat the I like a variable even though it's not a variable. Okay. But when we start multiplying, you do have to be a little careful because there are situations where you have to think just a little bit harder than you do with variables. Remember the relationship we talked about at the beginning, and in particular this one over here, that anytime we have I squared, that equals -1. So if we end up with an I squared in our answer, that means we can simplify our answer by switching that for -1. So what would that look like? Well, let's take this same problem, but instead of multiplying by 5, what if we multiplied by 5i? 5i times 3 plus 4i. So we're going to distribute 5i times 3 is 15i. 5i times 4i, got an I in both of those, so this time we're going to end up with plus 20, but then we've got I times I gives us I squared. I squared we can simplify, right? That is going to be equal to -1. How do we do that? Instead of 20 times I squared, write it as 20 times -1, changes the sign there, so we have 15i minus 20. And now, remember, if we want to put this in a plus bi form, put the part without the I first. So we're going to switch these. So we're going to -20 plus 15i. Our standard form, writing complex number. Anytime you see I squared, you've got to simplify. We don't want to leave an I squared in there. Okay, do another one. About this. 2 plus 3i minus hopefully this looks familiar. If these were x's instead of i's, we would use the FOIL method, just the extension of the distributive property. Okay, so we're going to do the same thing here. The only thing different is that at the end, if we have any I squareds involved, we have to simplify those. So here, do FOIL method, do 2 times 1 and get 2. Do the outer terms, 2 times -5i, get -10i. Do the inner terms, 3i times 1, it's positive 3i. Do the last terms, 3i times -5i, going to be -15. Got I times I, so that's I squared. See that I squared, you got to know you can't leave that. Okay. So if we get rid of our I squared, we've got 2, it's 10I, it's 3I. Here, remember, I squared is negative 1 times negative 15 turns into plus 15. And then we can combine like terms. So look, we've got 2 plus 15, that's 17. And we've got negative 10I plus 3I, that's negative 7I. That was 17 minus 7I, standard. Okay. Alright, one other thing that's a little trickier, so it's a little bit longer video. One thing that can be a little trickier than multiplying is if we had something that we to divide. We have like 2, 1 plus 2I. So here, when we think about dividing, really it's more similar to rationalizing when we have a square root in the bottom, because remember, I is the square root of 1. So the way we do this is we're going to multiply by something over itself, just like we do when we rationalize. And the specific thing that we want to rationalize, that we want to multiply by to rationalize, is called the complex conjugate. Pen's not working. Complex conjugate. That sounds scary. All it is, if we're going to multiply by the complex conjugate, we just take whatever we have in the denominator, we change the sign in the middle. So instead of 1 plus 2I, we're going to multiply by 1 minus 2I. If that had been 1 minus 2I in the bottom, go ahead and multiply by 1 plus 2I over 1 plus 2I. So you just change the sign in the middle, and just the middle one. You don't change the sign of the real part, you just change the sign of the imaginary. So if we do that on the top, I recommend not actually multiplying the top out unless you have a good reason to. So here I'm just going to write it 2 times. I'll leave it like that for right now. If I need to multiply it out later, I can. Bottom, we have to use the FOIL method here. Times 1 is 1. Outer terms, 1 times negative 2I is 2I. Terms, 2I times 1, 2I. The last terms, 2I times negative 2I is negative I squared. Remember, I squared, we can't leave that. Change it to negative 1. So, if we do that on the top, we have 2 times minus 2I. Bottom, we have 1. What happens here? We've got negative 2I plus 2I. These middle terms are going to cancel out, and that should happen every time if you multiply by the complex conjugate. That is our goal, to have those i's cancel out. Then on the end term, when we change I squared to negative 1, we had minus 4 times negative 1, so that turns into plus 4. So for our final answer here, 2 times 1 minus 2I, 5. Okay. And if you want to distribute that out, that's okay. You can also write that up. 2 minus 4I. Just distributed the 2 on the top. The reason why I don't distribute automatically is sometimes it cancels, like if we'd ended up with a 2 in the bottom. Just cross those 2. Okay, and if it says put it in a plus bi form, another trick is you take the first number 2, write it over the denominator 5, then it's a minus 4, write that over 5. The I goes on. It says put it in a plus bi form. You can split it into 2 fractions. Any of those are appropriate answers. If it says a plus bi form, then you want. Okay. Let's do another one. So on that one, I started with a plus sign bottom. Let's do sign. So here we want to divide. We're going to multiply by the complex conjugate over itself. We're going to do 2 plus 2i. 2 plus 2i. Switch the sign in the middle. So on the top we have 3 times 2 plus 2i over, get on the bottom, 2 times 2 is 4. 2 times 2i is 4i. Negative 2i times 2 is negative 4i. Negative 2i times positive 2i is negative 4i squared. Lots of 4. Sorry about that. 2 things to notice. This plus 4i minus 4i, that cancels out. And this I squared, sorry. What do we end up with? Let's leave the top like it is for right now. Bottom we have 4. Then negative 4 times negative 1 turns into plus 4. So we have e times 2 plus 2i, 8. Or if you distribute it, 6i, 8. Simplify. A plus bi form, get 6 over 8 plus 6 over 8i. 6 over 8 simplifies to 3 over 3/4. 3/4 plus I plus bi form. So this is the best at all the answers. Okay. Right. One other thing we need to be able to do. Try to do it really quickly so this video is not super long. So one other thing we need to be able to do. If you notice, when you raise I to a power, I to the first, anything to the first power is I. Well, actually, let's back up and start with I to the 0. Anything to the 0th power other than I to the first is I. I squared, talked about, that's negative 1. To the third, that's going to be negative 1 times I, so I. What's really neat is that if we keep going, if we do I to the 4th, well, that's I squared times I squared, so negative 1 times negative 1. That equals, take my word for it, do I to the 5th, I 6th, 1, I to the 7th, 5. So we have a pattern here. No matter what whole number power that we raise I to, it's going to be one of these 4 answers. And so that's something that doesn't happen in real numbers. So the last operation, the last thing we want to be able to do, we want to be able to simplify powers of I. So what if we have something like this? So if we have I to the 20th power, We want to be able to simplify this. It's going to either be 1, -1i, or -i. How do we figure out which one? Well, 20, right, our exponent of 20, we can break that down. So one technique we can do is try to break everything down into powers of 2, because we're supposed to remember that I squared, I to the second power, is -1. So if we do that, I to the 20th power we can write as I squared to the 10th power, right? Because 10 times 2 is 20. And then I squared, we know it's -1. Need to know what -1 to the 10th power is. So the shortcut here is if you raise -1 to an even power, it's +1. Raise -1 to an odd power, -1. Here we're raising -1 to an even power, so our answer is to the 20th is just. What about if we do a bigger one? It really doesn't get that much harder. What about I to like 50th power? 50 is 2 times 25, so I squared times to the 25th power, because 2 times 25 is 50. So this is -1 50th power. 50 is an even number, so again that is what if we do one that's a little trickier? So maybe we start with a power that's not even, so do like I to the 37th power. That's odd. So one way you can start out is we can say, well, it would be easier if I had an even number, so how about I change that to I to the 36 times I, because 36 plus 1 is 37. Now we just look at the I to the 36 part. 36 is 2 times 18, so I squared to the 18th power times I. 2 times 18 is 36, plus 1 is 37, so just rewritten. Got -1 to the 18th power. -1 to an even power is 1, so this is 1. I. One last one. We'll do a really big one. So I to the 2003 power. Well, if we could get it to 2000, it would be an even number. So let's do I to the 2000th times I to the 3rd. $2,000 is 2 times 1,000. So that's -1 to the 1,000th power times I to the 3rd. Even power, so we get times I to the 3rd. Now we can work with the I to the 3rd part. You can just remember it if you want. I to the 3rd is, so we can get rid of our 1. Just got I to the 3rd. I to the 3rd, I squared times I. I squared is -1 times I. So what do we end up with? We end up with -I. So I've always thought that's kind of neat that you can take these really big powers of I and they simplify out to one of 4 answers. We won't have to do that a lot, but it is good practice working with exponents. Okay, let me know if you have any questions. If you haven't seen, I extended the due date for this section a little bit, I think until Friday. So let me know if you have any questions.